Hi everyone, my name's Paul Lim. I'm in Mr. Bernabeo's first period class. So today I'm going to be talking about the absolute extrema and how to find it. And that's me right there. Okay, so let's start. So, what is the absolute extrema? Well, the absolute extrema is how big or how small the function could be. It's basically in the name absolute. When you think of absolute, you think of the utmost of something or the very low of something. So this is the same thing here. It's just showing how big or how small can the function ever be. So to find the absolute extrema, you plug in the critical points and the endpoints to actually show where the absolute extrema can truly occur. So on the next slide, I have a very vague example of a graph. So basically, to find the absolute extrema, you plug in the endpoints of the graph, which are shown here. And obviously, it's not very specific. It's supposed to be vague. I'll get into it later. But basically, in this graph, you plug in the endpoints to find the absolute extrema, and this is the regular function, original function. And you also plug in the critical values. Now remember, if this is the original function, how do we get the critical values? Well, you take the derivative. And when I mean to take the derivative, you take the slope. So when the slope is 0, that's how you get your critical values. So the slope is 0 at this point and at this point. So now that you know how to find the critical values, you plug in the critical values here and here, along with the endpoints to find the absolute extrema into whatever original function it gives you. Do not plug it into the first derivative, you plug it into the original. Now going into specifics, let's take the steps of how to find the absolute extrema. So first, check if the function is continuous on the interval. If it's not continuous on the interval, then you cannot solve it. But first, check if it's continuous on the interval. Second, find all critical points that only fit in the domain. If a critical point does not fit in the domain, then just slap it away. Like, it doesn't make sense if you plug it in because it's not in the function. So your third step is to evaluate the critical points and the endpoints into the original function. Again, do not plug it into the derivative, you plug it into the original function. And your last step is just to identify which value gives you the biggest and the smallest, meaning identify the absolute maximum or the minimum. So I provided an example here. This is the original function, the g of t function, which is 2t cubed plus 3t squared minus 12t plus 4 on the interval from -4 to 2. Now, our second step was to find all the critical points that only fit in the domain. So to find the critical points, again, we take the derivative. So when we take the derivative of the original function, we get 6t squared plus 6t minus 12. When we simplify this, we get 6 times t plus 2 times t minus 1. Now, common sense, we know how to find the critical values now. It's obviously -2 and 1. Now, Nikki's asking here, does it fit in the domain? Well, let's check. The domain is -4 to 2. The critical values that you got were -2 and 1, so yes, it does fit in the domain, so good job, Nikki. So let's evaluate. So remember, our domain was -4 and 2, or our endpoints, was x equals -4 and x equals 2. Our critical values which fit in the domain were x equals -2 and 1. So now we have 4 values to plug in. So that goes with our third step, so now let's actually do it. So now that we evaluated it, when we plug it into the original function, the g of t function, we got 24, -28, -3, and 8. So now we have to take step number 4 and check which value is the biggest and which value is the smallest, meaning which point gave me the biggest value and which point gave me the smallest value. So if we look over here, we have 24. If we compare it to all the other numbers, it is the biggest number. So this shows that x equals -2 gave the absolute maximum. Now, if we look for the very smallest number, we look at the negatives, and we see that -28 over here gives the the smallest value, meaning x equals -4 gives the absolute minimum. So yeah, that's basically how you find the absolute extrema of a function. So let's just go over the steps again. First, check if the function is continuous. We did check if it was continuous, and since it's a polynomial, all polynomials are continuous, so we got that on board. Second, we found that all the critical points only fit in the domain. Our critical points -2 and 1 fit in the domain from -4 to 2. Third, we evaluated the critical points and the endpoints included into the original function. Now we had 4 points, and we all plugged it in, and we got these 4 values. And we took the fourth step, we evaluated it, and we found the biggest and the smallest, and we got our answers here. So these are your absolute extremas. So remember to keep those steps in mind. Remember to always include the endpoints, because forgetting the endpoints is a common mistake that many students make. So remember to always make those small details, always include them, and never forget each step, because each step is very important to finding the very last answer. So thank you for listening to my tutorial, and I hope it was helpful. Bye.